So good morning, guys. This is Anjani Kumar, Electrical Department, Neurons Group of Institutions. I'm dealing the instrumentation subject for final year electrical students. Today I came with a different form of e-lectures because we don't have any blackboard to explain you with better neat sketches. You don't know each and every faculty facing lots of difficulties for providing these type of lectures for your education. So definitely you should follow these videos and make ourselves happy, right? In the last class we discussed about measuring system. We just completed two sessions, one session for introduction, another session for measuring system. So on different types of instruments also we completed. I just want to give brief remind for the last session what we completed. Basically, a measuring system means it consists of a measurement and instrumentation. Both clubbed together, we can call it as a measuring system. So, what is a measurement? Very, very important question. What is a measurement? Measurement means which measures the unknown quantity, which is compared to the standard quantity, and the result can be expressed in terms of a standard quantity. So, that is the definition of a measurement. So if you want to measure, definitely you require an instrument. So both measurement and instrument, we can call it as a measuring system. So basically the instruments are different types of instruments that are available in electrical systems. It depends on a methodology, how you are getting unknown quantity. Basically the instruments are classified into two types. The first one is absolute instrument, secondary instrument. We just completed all these things, but I just want to remind you guys. So what is absolute instrument? Absolute instruments are the instruments which measures the unknown quantity in terms of in terms of physical constants of that instruments. Physical constants of that instruments. That means if you want to measure a power, you require a formula. So you have to conduct the test for various results and put those results in that formula, you will get the result, right? But suppose if you want to find the power, you know the formula. What is the power formula? V into I. For this we just conduct the test in order to find out the voltage first. After that, conduct the test, find out the current first, then put in the formula. P is equal to VI. We will get the final result of the power. So this is a time consuming process, but we will get accurate results. So these type of instruments that we can use in a research laboratories. And what are the different types of absolute instrument we studied in the last session. And what is another one is a secondary instruments. So what is a secondary instruments? Secondary instruments are the instruments which measures the unknown quantity under the measurements itself and parameters measurement itself. Alright, so if you want to measure the power, definitely you require power meter, right? A watt meter. Directly you will get the result, no need to conduct any tests. Alright, if you want to find out the voltage, directly go for a voltmeter. Definitely you will get the result, standard result, no need to conduct the test, no need to find the formulas and all these things. It means what is the secondary instruments? Parameters under the measurements itself. Nowadays we are using these type of secondary instruments, right? A voltmeter, a ammeter, power watt meter, frequency meter, phase meter. These are directly will give the result, no need to conduct any tests, because there you don't have any accuracy, because there is a movement, mechanical movements, so there's some losses will be generated. We discussed all these things in the last session. And depends on mode of operations also. Secondary instruments are classified into deflection type, null type. Deflection type means we have a pointer, the pointer moves from zero position, and where the pointer stop, that's my unknown quantity. And null type instruments means bridge balance is there, na? Definitely if you want to find out the unknown quantity, galvanometer shows the null deflection. So when the galvanometer shows the null deflection, that's my unknown quantity. So these type of instrument examples means AC bridges, potentiometer, all these things works under secondary instruments. And after that, you know about analog instruments, digital instruments, and after that, mm, indicating type instruments, instantaneous values. Recording type instruments means it gives present and the past values also. Integrating type instruments and over a period of time, how much energy, sum of the energies that consumed by a particular load. So that will give some integrating type instruments. We studied all these things in the last session. So if some of the person need to analyze, you just go to the last session and understand those concepts, right? And today I'm going to deal about the characteristics of instruments. Definitely each and every instrument that it has some characteristics. Basically each and every instrument that it has two types of characteristics. The first one is a static characteristics and dynamic characteristics. You just follow my PDF along with the video, so with that I can clearly explain the concepts. Alright, so there are two types of characteristics: static characteristics and dynamic characteristics. So what is static characteristics? Static means it's a constant. These type of instruments which is having these type of characteristics, they won't change with the time, right? A dynamic characteristics means these type of characteristics with the instruments, there are changes with time and climate conditions and all these things. So that means static characteristics means stationary. That means it doesn't have any rotating. Rotating means that doesn't change with the time. Dynamic means it's change with the time also, right? Static characteristics. First we'll discuss about the static characteristics, which is very important questions. We don't have any questions related to dynamic characteristics, right? So what are the static characteristics? So static characteristics are two types. First one is a desirable static characteristics and undesirable static characteristics. The first one is a desirable static characteristics, undesirable static characteristics. What is desirable static characteristics? Desirable means sufficient. If you want to define any instrument, you should require these type of characteristics. Definitely you should produce these type of characteristics. Undesirable means you don't want to expect these type of characteristics for that instrument. If these type of characteristics present in that instrument, definitely the instrument will get damaged and the instrument will reach lots of errors, right? Static characteristics are desirable, undesirable static characteristics. Desirable means definitely you require sufficient, right? Undesirable means we don't expect these type of characteristics. If these type of characteristics present in the instrument, definitely the instrument will lose their efficiency, will get errors, right? What are the static characteristics? We'll see. Basically, the first static characteristic is accuracy, resolution. See, see, accuracy, resolution, precision, linearity, sensitivity, reproducibility, range or spam, right? These are desirable characteristics. So what are the desirable characteristics? Accuracy, resolution, precision, linearity, sensitivity, reproducibility or repeatability, range or spam, range comma spam. So these are desirable characteristics. Definitely these characteristics will be present in that instrument, right? So what are the undesirable static characteristics? Definitely there will be undesirable characteristics also present in the system. So those are hysteresis, dead zone, dead time, threshold, right? A drift and static errors. These are undesirable static characteristics. We don't want these type of characteristics in any instrument. If it present, definitely the instrument will get damaged in future, right? So what are the static characteristics? Static characteristics are accuracy, resolution, precision, linearity, sensitivity, reproducibility or repeatability, range, spam. and undesirable, hysteresis, dead zone, dead time, threshold, drift, static error. So these are static characteristics of any instrument. So I'll discuss one by one. Definitely you should follow my video. You should clearly understand, there is no doubt about that. Right? We'll start accuracy first. Right. So what is accuracy? So definition, it will be very difficult. If you follow one example, you should define yourself the definition, right? It is the degree of closeness to the measured value to the true value. You can call it as a accuracy. I think you people won't understand. Degree of closeness to the measured value to the true value, you can call it as a accuracy. We'll see. I just want to measure 5 volts. I just want to measure 5 volts. So that is my true value. How much value you are going to measure? 5 volts. You want to measure. I have two instruments. So those instruments are 0 to 10 volts voltmeters. 0 to 10 volts voltmeters. I have two instruments. Alright? Two instruments. Now you started. You require 5 volts. For the first instrument, you conduct the test, you'll get the result of 4 volts. Right? With that second instrument, you conduct the test, you'll get the 2 volts. Right? So which one is more accurate means which is very closest. This we can call it as a measured value. After the test, you'll get the result now. So that is called a measured value. So what is a true value? How much you want to measure? That is a true value. Right? After the test, you will get the result now. That is a measured value. See, in order to find the 5 volts for the first instrument, you will get the 4 volts. Second instrument, you will get the 2 volts. Right? This is a measured value and that is a true value. So the degree of closeness from the measured value to the true value, which is the measured value 4 volts. What is the true value? 5 volts. Degree of closeness to the measured value to the true value, we can call it as a accuracy. That means this instrument will give some more accurate instrument and this instrument will give the less accurate instrument. I hope you understand the accuracy. Accuracy means how much closest to the true value, right? And more accurate means I have that much ability, right? The accuracy can be specified plus or minus error also, right? Plus or minus errors also. For suppose I have a 4, I just want to measure 5 volts. After conducting test, you will get 4 volts. So what is that error? 1% error or 3% error. You can say accuracy that can be expressed in terms of plus or minus n% of error also. Accuracy can be specified with respect to full scale also or a specific value. So accuracy is 1. 0 to 10 volt scale, accuracy is 1. Right? That is not that much important. Right? So you won't get 0% accuracy. Right? You won't have that much of instrument like a 0% accuracy instrument. So you don't have it in electrical systems. So what is meant by accuracy? Accuracy means a degree of closeness to the measured value to the true value. You can call it as an accuracy. Accuracy that can be expressed in terms of plus or minus n% of error. N may be 1, 2, 3 error also. It can be expressed in either full scale or particular value. So you don't get a 0% accuracy of the system, right? So this is about accuracy. I hope you people understand. Now we'll go for a resolution. This is very, very important. The resolution means the smallest change in the instrument that we can measure. The smallest change in the instrument that you can measure. So those type of instruments, you can call it as a high resolution instruments. See, I'll explain with the examples also. See, I have a scale is like this, right? Scale which is having a divisions 0, 2, 4, 6, 6, 8. This is a scale. I don't have any divisions. But suppose my pointer is at this point. My pointer is at this point. It is very difficult. How much quantity, how much unknown quantity. This is the smallest change, na? 2 to 4. There is the smallest change. You don't know that change. So these type of instruments are low resoluted instrument. You don't know. You'll directly say 2.5, 2.6. That's not that much accurate. So for this, you require number of divisions. That means I have a scale 0 to 20. Each and every scale, every division divided by 5. Right? Number of scale is 20. Each and scale is having number of division. For suppose I have a scale 2 to 4. Now my point is struck between 2 to 4. You know each division how much value. That will tells the resolution. So how much? So total full scale and the 20. How many divisions? Total 50. 50 divisions is there. Total number of divisions. Each division is 5. 5, 5, 10, 15, 20, 25. That means 50 divisions is there. So 20 full scale, number of divisions 50. That means each point, each division reveals 0.4. You know, each and every division is 0.4. Now my pointer stuck between 2 to 4 at any point. You will directly tell how much value of that unknown quantity. Right? I hope understand. Resolution means smallest change in the instrument that we can detect. So those type of instruments are called highly resoluted instruments. Got it now? So if you want to measure, if you want to know the resolution of the system, you definitely require number of divisions. If you know the number of divisions only, you can easily identify the resolution of the system. So you have a formula. So resolution means full scale reading by number of divisions. That means what is the full scale reading here? 20. So how many the number of divisions? 50. So what is the resolution? 20 by 50, 0.4. That means each and division will represent the 0.4. ప్రతి డివిజన్ నీకు తెలుసు, ఈచ్ అండ్ ఎవ్రీ డివిజన్ తెలుసు. ఇప్పుడు పాయింటర్ 2కి 4కి మధ్యలో ఎక్కడ ఆగినా కూడా యూ విల్ సే. సో దట్ ఈస్ అన్నోన్ క్వాంటిటీ. రైట్? డైరెక్ట్లీ సే. Right? That means if number of divisions increases, definitely the resolution also increases. Na? Ekkada point struck aina, you can easily retrieve that value. Right? So the resolution means the smallest change in the instrument that you can easily detect. So for this resolution, you require number of divisions. Right? From that you can identify how much resolution it is. So what is the formula for resolution? Full scale reading by number of divisions. ఇప్పుడు ఈ స్కేల్ 2కి 4కి ఆర్ 6కి 8కి మధ్యలో ఎక్కడ ఆగినా కూడా యూ కెన్ ఈజీలీ టెల్. ఫర్ సపోజ్ 6కి 8కి మధ్య 5 పాయింట్లు ఉన్నాయి. 5 పాయింట్లు ఏ పాయింట్లు ఆగినా యూ విల్ ఈజీలీ ఐడెంటిఫై హౌ మచ్ అన్నోన్ క్వాంటిటీ ఇట్ ఈస్. ఈచ్ అండ్ ఎవ్రీ పాయింట్ రివీల్స్ 0.4, 6.4, 6.8. ఎక్కడ ఆగితే అక్కడ ఆన్సర్ చెప్పేయచ్చు. Right? So that is a perfect resoluted instruments. I have some problems. These problems are very, very important problems. These problems from A.K. Sahani. Listen. A 0 to 200 volts voltmeter having 100 divisions. 100 divisions. 0, 2, 4, 6, 8 like 100 divisions. And 1/10th of each divisions can be estimated. Each division lo 10 ఉంటాయి మళ్ళీ. రైట్? ఒక డివిజన్లో 10 ఉంటాయి మళ్ళీ. దెన్ వాట్ ఈస్ ద రెజల్యూషన్? యూ విల్ సే ద రెజల్యూషన్. రెజల్యూషన్ మీన్స్ ఫుల్ స్కేల్ రీడింగ్ బై నెంబర్ ఆఫ్ డివిజన్స్. సో వాట్ ఈస్ ద ఫుల్ స్కేల్ రీడింగ్ హియర్? సో వాట్ ఈస్ ద ఫుల్ స్కేల్? 0 to 200. సో వాట్ ఈస్ ద ఫుల్ స్కేల్? ఫుల్ స్కేల్ మీన్స్ లాస్ట్ మ్యాక్సిమం పాయింట్ ఏంటి? 200. సో వాట్ ఈస్ ద ఫుల్ స్కేల్? 200 బై నెంబర్ ఆఫ్ డివిజన్స్. నెంబర్ ఆఫ్ డివిజన్స్ ఎన్ని? 100. 100 divisions is each division mala subdivision 1/10th of each division. 100 by 1/10. So what is the value? What is the value? 0.2. So each division represents the 0.2. You know each division value. If a point ekkadaina struck aina, you can easily retrieve the unknown quantity. So that is the resolution. Right? Or one more problem. A moving coil ammeter has a uniform scale of 50 divisions and gives a full scale reading 5 amperes. The instrument can read up to 1/4 of scale of each. What is the resolution? So resolution means full scale by number of division. Full scale and 5 amperes, right? 5 amperes is a full scale by how many divisions? Number of divisions 50, right? Each division subdivisions and 1/4. So what is that value? 0.25 amperes. So each and every division in that scale represent 0.25. Right? For suppose 0.25 means, for suppose I have a scale like this, 0, 2. That means 0.25 అనమాట. రైట్ 0.25 నాకు స్కేల్ మధ్యలో ఆగిందనుకో, నువ్వు క్యాలిక్యులేట్ చేసుకోవచ్చు. 0.25 యాడ్ చేసుకోవడం, యూ కెన్ ఈజీలీ టెల్ ద అన్నోన్ క్వాంటిటీ. సో దట్ ఈస్ కాల్డ్ a resolution. Right? We completed two static characteristics. What are that? Accuracy, resolution. So what is accuracy? Degree of closeness to the measured value to the true value. You can call it as an accurate instrument. After that, resolution means the smallest change in the instrument that we can detect. You can call it as a resoluted instruments. And one more concept is, third characteristic is a precision. So what is meant by precision? Precision means reproducibility or consistency in the instrument. We can call it as a precise instrument. I'll clearly explain with example. For suppose I just want to find a 5 volts. Right? I have a two instruments, 0 to 10 volts instrument in the 0 to 10 volts and another instrument is there. Right? First one instrument, I'm using one instrument. Right? Experiment చేసా, I'll get the result as 2 volts. So see, I just want to find 5 volts. I have a two instrument. What are that instrument? 0 to 10 volts instruments, another 0 to 10 volts instruments. Right? I started experiment. First instruments, so I am doing experiment. Each and every time I am getting a result of 2 volts. Each and every time I am getting a 2 volts. That means repeatability, reproducibility. Each and every time my output is 2 volts. So these type of instrument, you can call it as a high precise instrument. రైట్? నువ్వు 5 volts మెజర్ చేయడానికి నువ్వు 0 to 10 volts ఇన్స్ట్రుమెంట్స్ తీసుకున్నావు, టెస్ట్ కండక్ట్ చేసావు, నీకు ఈచ్ అండ్ ఎవ్రీ టైమ్ యూ ఆర్ గెటింగ్ 2 volts. సో దీస్ టైప్ ఆఫ్ ఇన్స్ట్రుమెంట్ యూ కెన్ కాల్ ఇట్ యాజ్ ఎ హై ప్రిసైజ్ ఇన్స్ట్రుమెంట్స్. సో వాట్ అబౌట్ యాక్యురసీ? 5 voltsకి 2 voltsకి లాట్స్ ఆఫ్ డిఫరెన్స్ నా. దట్ మీన్స్ లో యాక్యురేట్ ఇన్స్ట్రుమెంట్. దట్ మీన్స్ హై ప్రిసైజ్ లో యాక్యురేట్ ఇన్స్ట్రుమెంట్. ఎల్సి 0 to 5 volts మెజర్ చేయాలంటే 2 volts, you got each and every time 2 volts. That means high precise instrument, but accuracy is very less. And one more instrument, you conduct the test, you will get the result of 4.5, 4.3, 4.2, 4.4. Doesn't have any reproducibility. That means these type of instruments is low precise instrument. What about the accuracy? The accuracy is high, low precise and high accuracy instrument. In this you have to very important note. This is very important. All precise instruments, this is very important. All precise instrument may not be accurate. Right? See, this is high precision, na? This is high precise, but what about accuracy? Don't have any accuracy. Right? But all accurate. This is our accurate instrument na. 4.5 means very accurate, 4.3 means very accurate. All accurate instruments may be precise. This is the precision na. 4.5. That means somewhat precise. Definitely there will be a precision. So what is the concept? What is the note? It is all precise instrument may not be accurate. All accurate instrument may be precise. Right? So that is very important question. So the gate question. So right now, what is a precision? So what is a precision? Precision means reproducibility, consistency in the output. Right? For example, if you want to find out the 5 volts, okay, instrument తీసుకున్నాం, you are getting each and every time 2 volts. So that means high precise instrument. What about the accuracy? Low accuracy. And after that, ఇంకొక ఇన్స్ట్రుమెంట్ తీసుకున్నావు, నెక్స్ట్ టెస్ట్ కండక్ట్ చేసావు, యూ ఆర్ గెటింగ్ 4.5, 4.3, 4.2, 4.4, 4.1. ఈచ్ అండ్ ఎవ్రీ టైమ్ యూ ఆర్ గెటింగ్ దీస్ రిజల్ట్స్, విచ్ ఈస్ లో ప్రిసైజ్ ఇన్స్ట్రుమెంట్. రిప్రొడ్యూసిబిలిటీ లేదు కదా. low precise instrument. What about the accuracy? Very high, right? That means the note is all precise instruments. All precise instrument may not be accurate, or but all accurate instrument may be precise. This is very very important bit, right? So okay, thank you. In the next lesson I'll continue this precision, because the length of video is getting more. That means it's very difficult. You people should download these type of videos. So thank you, keep watching my videos. Thank you.